All right, we're going to take a look at section 5.2, dividing polynomials. There's two different types of division we're going to use. The first is long division, and you've done long division, I hope, at some point before. To practice it, let's do something that's not polynomials at all. Let's take, I don't know, 2,421, and we're going to divide it by 15. So if we did long division, we're dividing by 15, that goes in the front, and we're dividing the 2,421. And so what you do with long division is you consider this number out front, the 15, and you say, well, how many 15s go into, and then just go like a digit at a time, 2. Well, that's not possible. 15 doesn't go into 2. So then consider the first two digits, 24. How many times does 15 go into 24? Well, it goes in there once. So we put a 1 up there. And then we do multiplication. We're going to do 1 15. So 1 15 is a 15. So we write that down below, and we subtract that away from the 24. If we subtract 15 away from 24, we're left with 9. Go ahead and drop the rest of the digits down. So now we have 9, well, really, this is in the 100 spot. So we've done a 100. We still have 921 remaining. So now we'll repeat the process. So 15 doesn't go into 9, but 15 goes into 92 6 times. So we'd put a 6 in the 10 spot. 6 15s is 90. So we subtract that away. We get a 2 and a 1. So we carry down that 1, so 21. So now I have 21. Well, 15 goes into 21 one time. So in the 1 spot I have a 1. 1 15 is 15. Subtract that away, and I get 6. There are no other numbers. 15 doesn't go into 6, so this is a remainder. And you learn probably to do remainders a few different ways, but sorry. So we have 1 to 61, and here's one way we could do the remainder. You had 6 15ths because you were dividing by 15. Now, in our case, that simplifies because I can divide 6 and 15 both by 3. But for the sake of what we're going to do today, let's just go ahead and leave it like that, because typically what we have today probably won't simplify any further. So that would be your answer. So now we're going to follow that process, long division, to divide two polynomials. So what I want to do is I want to take 6z to the 6th plus 3z to the 4th minus 9z squared. I want to take that polynomial and I want to divide it by this polynomial. I want to divide it by 3z minus 6. And so if I'm doing long division, I'll set it up similar to the last one. I'm dividing by the 3z minus 6, so that will go up front. Now when I put this polynomial in here, I'm going to watch for missing terms. It's kind of important. Some problems it's more important than others, but we're just going to get in the process of always watching for it, because otherwise sometimes you don't watch for it, you'll get burned by it. So the largest exponent is 6, so it's a 6th degree polynomial. I'll start with that. And then after 6 will be a 5. I don't have a 5th degree term, so there's really 0 of them, but let's go ahead and include that. And then descend our way down from there. So next is 4. We have a 4th degree term. Next is a 3rd degree. We don't have one of those. So 0, z to the 3rd, z to the 2nd. We do have. Continue descending from there. We would look for a z. We don't have one of those, so it's a plus 0z. And then after that, we should have our constant, which we don't have that either. It's a 0. So we do have lots of zeros here. And so now I take, and what I'm really going to do is look at the first term here, the 3z, and say, well, how many times does 3z go into 6z to the 6th? Well, 2, and then z goes into z to the 6th, or, we'd have to take z times z to the 5th. So we get a 2 and a z to the 5th. So I'm going to align it with my other z to the 5th term here. And so that's going to be my multiplier. I'm going to multiply that to this polynomial out here. So 2z to the 5th times 3z. That's 6z to the 6th. And then continue distributing. 2z to the 5th times negative 6 is negative 12z to the 5th. What I'm going to do now is I'm going to subtract that polynomial. Oops, sorry, I just realized I wrote it, I didn't even write it in the right spot. I meant to align it here. Let me do a little erasing here. 6z to the sixth should go under the z to the sixth term. And then the negative 12 z to the fifth should align with the z to the fifth term. It's going to make a lot more sense. Okay. Sorry if I confused anybody with that. So now we can go ahead and subtract. Now we're subtracting like terms. 6z to the 6 minus 6z to the 6, it becomes a 0. That's great. I'm not even going to bother writing it. So now 0z to the 5th minus 12z to the 5th. And I'm subtracting. Don't forget that. It might be a good idea when you subtract to distribute the signs. You don't forget that. So otherwise that's probably the temptation. So here we actually add. So I have 12z to the 5th. Go ahead and drop the remaining terms. And now we repeat the process. How many times does 3z go into 12z to the 5th? Well, when you multiply a 4 and then z to the 4th. So positive 4z to the 4th. So now I'll take that, the 4z to the 4th, and I'll distribute to that polynomial. So 4 times 3 is 12. And then z to the 4th times z is z to the 5th. 4z to the 4th times negative 6 is negative 24z to the 4th. So I'm going to subtract that. But it might be a good idea to distribute that sign so we don't forget it partway through. The z to the 5th cancels, so now I end up with 27z to the 4th. And we drop the rest of our terms. And repeat the process. We just keep going now. 3z goes into 27z to the 4th, 9z to the 3rd times. And so now I take that 9z to the 3rd, multiply it, distribute it to my polynomial, 27z to the 4th, and negative 54z to the 3rd. Notice if I hadn't put this 0 there, this z to the 3rd would not have aligned with the next term, and that would have potentially been an issue. Now I subtract it. I'm going to distribute my subtraction. Z to the 4ths cancel. 0z to the 3rd and a positive 54 z to the 3rd. I've got a positive 54. Z to the 3rd. Drop the rest of the terms. All right. 3 goes into 54 18 times. So I need 18z to the 2nd. Minus, I've got 6 times 18, 39, 108, I believe. Yeah, sorry, I was just thinking through. I want to make sure I did that math correctly. It looks like I did it right. I'm going to distribute my negative. So there's a negative and a positive. Now subtract those, they cancel. I'm going to get a positive 99 z to the 2nd. So how many times does 3z go into 99z to the 2nd? Well, 33, a positive 33z times. Distribute 99z to the 2nd minus 198z. I'm subtracting that, distribute. (198z) plus 0. How many times does 3z go into 198? So we've got 66. No z's. Okay, so distribute. 198z minus, this is going to be 396. Distribute, and I put just 396. Z doesn't go in there. This degree is now smaller, so this is my remainder. So what I will do at the end is I will add a fraction. The 396 goes in the top of my remainder, and what I'm dividing by, 3z minus 6, goes in the denominator. And so there's my answer. Now, as it turns out, this remainder actually can simplify because I could factor out 3 from the denominator and divide it by the numerator. So that really would become a 1/3 32 over z minus 2 would be a more proper remainder there. But you've got the idea. That's how we do long division. And that's a lot of work. It takes a lot of time, and because that, we try to do as little of long division as possible, but there are times where we need to do it. And the times where we need to do it are when we're dividing. Think about what we're dividing by. If this is a z squared or bigger, we definitely have to. But if it's just a linear term, like if it's just z, or maybe it's the letter x, that's fine, but it has a coefficient in front, then we'll go ahead and do it too. Now our textbook does show a way that if you have a linear term like this with a coefficient in front, you can still do our next method. You're welcome to take a look at that in the book and do it. It deals with a lot of fractions, and that's okay to do, but I've opted to just stick with long division when it's that case, so we can avoid some of those fractions. But there is a way. But I don't want to do another example of this right now, but I'm going to go into what we call synthetic division. It's the shortcut way to do some types of division. Okay, so sorry, I need to get another sheet of paper. I took up basically the whole sheet on that problem. So we're ready for example number 2. And we're going to do this problem. We're going to take 3, kind of a long one again, 3z to the 4th minus 6z to the 3rd minus 9z squared plus 3z minus 6. And we're going to divide it by z plus 3. So what I'm about to show you, we call this synthetic division. It's much quicker, partly because we're not even going to bother writing the z's over and over again. We're just going to deal with numbers. And this works as long as you're dividing by a linear term, so just a z or an x, and then there can be a constant added at the end. But we're going to do it once again with no coefficient in front. If there is a coefficient in front, we're going with long division. So here's what you do. You take what you're dividing, the 3z to the 4th minus 6z to the 3rd minus 9z squared plus 3z minus 6. Check and make sure that it's in descending order. Largest exponent, work your way down. Check to see if you have any missing terms. Sometimes you'll skip a variable, or skip an exponent. In this case, I didn't skip any exponents. 4, 3, 2, and then the z would be of 1. And your constant is a 0. So 4, 3, 2, 1, 0. I did not skip any. That's great. If we did, we would have to fill in a 0. Then here's what you're going to do. We're going to leave a little space out front, but then I'm going to just list those coefficients in order. Leave some room in between them. Go to 3. My next coefficient was a negative 6. My next one was a negative 9. Make sure you get the signs with them. Next one was a positive 3, and the last one was a negative 6. Out in front, because remember I said leave a little bit of space in front, I'm going to make a little half box. I'm going to put a number in this box. The number that I'm putting in this box has to do with what we're dividing by. We're dividing by z plus 3. Now, if we think of this as a factor, and we were finding solutions, remember when you have a factor, you set it equal to 0, and you solve, you would subtract the 3 away, and I'd have a negative 3. That's the number that's going to go in the box, the half box. You see z plus 3, I put a negative 3 there. Now, we're going to leave some space for another line. I'm going to go ahead and create this horizontal bar, but I'm going to write numbers above it, so I leave some space, and then I dropped a little vertical bar right before that negative 6. Here's what's going to happen. Your first number, your first coefficient, you're going to drop it straight down because that's going to be the first coefficient in our answer. But then as soon as we get a number down below the line, it's going to be multiplied by the number in the half box. So you have a negative 3 there. It becomes a multiplier on the 3. 3 times negative 3 is negative 9, and you're going to write that under the next coefficient. And then it becomes an addition problem. Add those together. It's not subtraction like long division, just combine them. We already dealt with the subtraction by changing the sign here. So just add those together, it's a negative 15. That's going to be the second coefficient in my answer. Now, take that, since we got a number down below the line, when we multiply it by our little multiplier up here, negative 3 times negative 15 becomes positive 45. Write that here. Add those together. 36. multiply it by the negative 3. Negative 108. Combine those, that's a negative 105. Sometimes our numbers just kind of get bigger, progressively bigger, bigger, bigger. That's what's happening here. Negative 3 times negative 105 is positive 315. Combine that with the negative 6, I get 309. What I have here are the coefficients of my answer. The last number is my remainder. Now all I have to do is go ahead and put my variables and their exponents with them. But what's happened, since we divided by a z, which was a degree of 1, it's a linear term, we've descended 1 degree. We divided out a degree. So we had z to the 4th, we really divided it by a z, so we end up now with z to the 3rd. We always descend 1 degree from what we started with. That was z to the 4th, this will be z to the 3rd. And then now you can just descend from there. So negative 15 would be z squared. The positive 36, would be z. The negative 105 would be my constant, no variable, and then this positive 309 is my remainder. So we're with the remainder in the numerator, and we divided not by negative 3, we actually divided by z plus 3. That goes in the denominator, and there's my answer. You notice that's a lot shorter, a lot less space than what it takes when you do long division. That's why it's much preferable when you're allowed to do it. We're going to try another one. Take y to the 5th minus 3y squared. Notice I just skipped some terms there. That's important to realize. Minus 20. I skipped another term. And we're going to divide by y minus 2. Good news. We're divided by something that's linear. There's no exponent on the y, and there's no coefficient. So this is a perfect synthetic division problem. Because it's y minus 2, I'm going to put a positive 2 in my little box. And then I'm going to list out my coefficients. Make sure it's in descending order, and check for any missing terms. My largest exponent is 5, and it has a coefficient of 1. So 1 is my first coefficient. Then if I descend from there, think about your y to the 4th. There wasn't one, so that's a 0. So my second coefficient is 0. Then it would be y to the 3rd. I don't have one of those either, so it's also a 0. 0 y to the 3rd. Y to the 2nd, I do have that, so that's a negative 3. After y to the 2nd, it should be y to the 1st, or just y. I don't have one of those either, so there's another 0. Then my constant would come next, negative 20, I do have that. Okay, so there's all my coefficients. You will have problems if you miss any of those zeros. Your answer will not be correct, so you got to be careful about that. Now we repeat that process we did up above. Drop the first number straight down. Once you get a number below the line, multiply it by your multiplier, just 2. And then add. 0 plus 2 is 2. Use the multiplier. 2 times 2 is 4. Add, we get 4. Use the multiplier. 2 times 4 is 8. Add, we get 5. 5 times 2 is 10. Add, we get 10. 2 times 10 is 20. Add those together, you get 0. No remainder. Oh, that means it was actually divisible by y minus 2. I just actually factored it out, which is kind of nice. So when I divided it, here's what I'm left with. 1 what? Well, this was y to the 5th, so this is 1 y to the 4th. I don't have to write the 1 if it's just a coefficient of 1. And then I have 2 y to the 3rds. So then I have 4 y to the 2nds. 5 y's. 10 constants. Since there's no remainder of 0, I don't need to write the remainder. And there's my answer. All right, there's some quick notes on division.